Welcome back to another Algebra 2 video. I'm Mr. Hibble. Today we're looking at factoring difference of squares. This is part of our 5.2 notes. Difference of squares is just a shortcut method of factoring when you have the difference of two squares. What that means is you might have something squared, maybe let's say a squared, whatever it is. It needs to be a difference. It does need to be subtraction. And you have something else squared. So you have two squares with subtraction in the middle. Well, if you have something in this form, there's a shortcut you're allowed to take where the shortcut states that your factored form just takes whatever's being squared, a and b in our case, you add them and you subtract them in your factors. For example, let's look at this first one here, x squared minus 16. But we know x squared is already something squared, so that one's easy. But 16 is not written as something squared right now. Well, one thing we know is that 4 squared is the same thing as 16, so we could change it. Well, now that we have this form above of something squared minus something squared, you can go straight to your factored form, where those two things are adding and subtracting. Whatever gets squared, which was the x and the 4, they add and subtract in your final factored form. Realize this is equivalent, okay? That's all that we needed to do on our problem. That is the answer. What I want to do is go off to the side and show that those two things are the same. So I want to prove that these are equal. Well, one way we might do that is we might start to multiply this right side out, right? You're in factored form. You have two different parentheses multiplying. We've been showing our multiplication like this, where you take what's in the first parenthesis, multiply it with the second, as well as the 4, again, multiplying with the second, and we could distribute. You could take x, multiply that to the inside. You could take the 4, multiply that to the inside, and get your final answer. Well, once we have that, you can combine your like terms, and notice these middle terms. This will always be true with difference of squares, is the middle term should always cancel. Negative 4 plus 4 is 0. That does go away. All we're left with then is x squared minus 16. Realize if you had a plus in the middle instead of the minus, if it was a sum instead of a difference, that middle term would no longer cancel out, and this process does not work. Let's look at a few more examples continuing this factor. This second one here, change them to both be something squared, so maybe I'd change it to now be 5 squared and x squared. It is subtraction, so that's good. Once you have it set up, you take those two things, you make them add and make them subtract. The order inside does matter. The 5 was the first thing we had, so it should be the first thing in the parentheses. The x is what was being subtracted, so it should be the thing that has the minus in front of it in the parentheses. That is our factored form. Looking at this next one, first thing I notice is now there's this plus in the middle. Again, if there's a plus, this process doesn't work. The only thing you could try to do is factor a GCF out when it's two terms like this, but even that doesn't work in this case. This one we call not factorable. Factorable. I don't know why my marker's being annoying. Okay, it's not factorable. That is known as prime. If something's already in its factored form or it's not factorable, that is called prime. Next one, continue your process. Find what squared gives you what is shown. In this case, 4 is the same thing as 2 squared. X is just x squared, and 121 is 11 squared. Take your values, put them in your parentheses in your factored form, and you have your answer. Realize the order of these parentheses does not matter. The minus could be first and then the plus. The order of your parentheses doesn't matter, as the order of multiplication does not matter. This next one's a little bit weirder. We have x to the 4th minus 225. So one thing we might need to note is we've been taking x and squaring it. We're saying that's the same thing as x squared. Well, x on the inside technically has an exponent of 1. So what we're doing is we're giving x this multiple exponents idea, x to the first and to the second. Well, when something has multiple exponents, what you're doing is you're multiplying those. So this is really x to the 1 times 2, which does get us x squared. If you had something like x to the third and then raised to the fourth, again, you would multiply those together, in this case giving you x to the 12th. Multiple exponents means you multiply the exponents. Well, in this one, we need to change it to something squared minus something squared. The second part should be easy, but the x to the fourth is the weird thing. Well, we need to say that two things, two exponents multiplied together to give us 4. Well, what times 2 gives us 4? We know that value would be 2. So what we're allowed to do is change x to the fourth to be x squared squared. It has multiple exponents. And then from there, putting it in your factored form should be quick. Again, taking whatever's being squared, adding it, and subtracting it. That is how we factor using difference of squares. But we don't normally just factor. We normally do more than that. We usually figure out what the actual solutions are. We actually solve these problems. So we find our difference of squares. We find what the factored form should look like. 5 plus 6x, 5 minus 6x. That whole thing is equal to 0. And much like we saw in the last video for 5.2, once you have your factored form, you can take those factors, set both parts equal to 0, and solve this. That means I can start to move the different values away from x until x is by itself. One solution you'd end up finding is negative 5 over 6. Same idea, same sort of process on the other side. Your value will change slightly, just giving us the positive version, as a negative divided by a negative cancels. There are the two solutions we get when we solve this difference of squares problem. Okay, but what if we have something like this, x to the fourth minus 64? Well, one thing we just learned is x to the fourth is the same thing as x squared squared, and 64 is the same thing as 8 squared. Okay, well, x squared squared and 8 squared, okay, we can make our factored form. X squared plus 8, x squared minus 8, all of that equal to 0. It's in the factored form, so I can separate it, set both parts equal to 0, and solve each of those individually. Meaning I could subtract 8 on both sides, giving me x squared equals negative 8. I could get rid of the squared. The opposite of squaring something is square rooting. So, okay, x is equal to what? And remember, when you take a square root on both sides, you always need plus or minus. Square root of a negative in this case. Square roots of negatives are not possible, so we always use I, the imaginary number. And square root of 8, we don't know it, so we might just leave it as square root of 8. Okay? I'm fine with that for now. We'll talk about simplifying that to actually end this video if you need that reminder. X squared equals 8 on this other one. Get rid of the squared. X equals plus or minus 8. There is no I, as that value of 8 was positive. Okay, well, those are your answers. If you have it like that, I'm okay with that for now. But remember, we know how to simplify square roots. You can take the square root of 8. You can divide it by the perfect squares lower than it. You divide it by 4. You divide it by 1, right? You divide by the different perfect squares. And you would find that the perfect square of 4 goes in 2 times. Well, remember, the square root of 4 is just a value of 2. The square root of 2 does not change. So the square root of 8 in both of these answers could really change. We could change our first answer to be plus or minus 2. The I is still there. Instead of square root of 8, we now have square root of 2. Or for the second answer, instead of square root of 8, we would just have 2 square root of 2. And that would be your final answers as well. Those are equivalent forms to the top answers we listed here. Okay, that is our 5.2 video. Thank you for watching.